Excellent. Okay, so we are going to start on lab 7. So this will be the last of the current labs that we have that will focus on front end, at least for now. In this lab, we will build a quiz game that maintains a leaderboard. So in here, the big takeaways are we're going to learn what a REST client app is. And to build a REST client app, it's going to be dependent on concepts that are related to HTTP and the JavaScript Fetch API. So we've kind of seen a little bit of this in the prior lab when we did the contact form. And then we're also going to look at another thing that we haven't looked at yet, JavaScript modules. Now, there's a lecture series on JavaScript modules. There's also a lecture series on the asynchronous JavaScript. And any questions you might have on the code base should probably be answered there. But the modules will be a better way for us to start organizing our code. Now, one thing about the modules is they do require us to host our page as on a web server and not use the file protocol. So we will require HTTP protocol, so that the general breakdown for this lab, we could think of it as effectively 2 parts. We have part 0, which is where we kind of break down the learning concept so that you understand the purpose of the lab, not just to build an application, but what you're supposed to learn en route to building that application. And here, again, it's because we really want to hammer on these concepts of HTTP requests that come from the client. And in this lab, we're going to pivot away. Last lab, we learned how to use a post request to go ahead and publish or to write data, create data onto the Google form. Here, we're going to use get request and we're going to use put request alongside with the fetch methods inside of JavaScript. And that fetch method is an asynchronous method. So we use the async keyword with the await keyword. So if a function requires uses an await on a function call, like on fetch, then it has to be asynchronous. And then we're going to learn about a little bit about JSON. JSON, it gets covered slightly in lecture 9 on standard objects. We look at the JSON object. It's a way of serializing our JavaScript objects. In fact, JSON stands for JavaScript Object Notation, but it's actually become kind of a dominant way of making human readable serialized code. And so for that reason, it's used in other languages outside of just JavaScript as a means of configuring applications. And then we're going to look at modules. So those are all going to be the new things we want to learn how to use. We're also going to talk about what it means to be a REST client. And we're going to design a browser app that sends HTTP requests to REST APIs. So once we cover goal 0, we can start talking about actually building our application. Our application will be in 2 parts. Part 1 will be a quiz game, and it'll be broken down across 7 goals because we're going to take an iterative approach to building out our application where we do it a step at a time, just like all of our other applications. And so effectively, the first thing we'll do is we'll look at a pre-existing REST API that we can request trivia questions from. This way, we don't have to go through the process of building our own sets of questions and answers. We're going to find a service that does that, and we're going to request questions as we need them to go ahead and publish them into our game. So the next thing we want to do would be to actually go ahead and send a GET request to that to that web server so that we can get a trivia question and answer. Then we'll take the returned data, which will be in the form of a JSON, and we'll want to go ahead and display it into our viewport on our browser using the document object model. Then once we get the question to display, we'll do the very same thing with the answer. And then after we get the question and the answer to make it an actual game, we'll look at building timer events. Oh, yeah. There we go. We'll look at building timer events to display the HUD. And then we'll create a game over scenario. And then we'll build it such that we can have a next trivia question And then finally, we'll have the ability to submit an answer and handle that outcome. And then that'll give us at least a minimal viable product for our quiz game. And then once we do that, then we can consider building part 2 of our game, where we actually focus on doing a leaderboard in order to get a leaderboard that's shared across every client, not just the local client, because that's going to be the goal here. We're going to look at another API called JSON bin that will allow us to store data on effectively a remote server, so that when anyone loads to our quiz page, they'll be able to see publicly the scores, the top scores everyone who played this game will have had. So these top scores won't be local, they'll actually be global. Then we'll build a main menu where we will display the leaderboard, and then we'll have to make a request to get the leaderboard, play it into the DOM from a JSON, and then be able to put new scores into the leaderboard. And we'll manage that using events and HTTP. So that's effectively the breakdown of this lab. And I'm hoping to get through part 1 today. So a quick introduction on this lab. The prereqs, you should know a little bit about HTTP protocol, which we've covered already in the prior lab. And of course, I have the lecture videos that are published on it as well. In terms of software requirements, we will have to go ahead and host our page on a web server and not just open it using the file protocol. And the reason why is because we want to make use of JavaScript modules, and JavaScript modules are not allowed to be opened in the file protocol. So we're going to start pivoting to testing our applications using web servers. So there's one of 2 web servers you can use. You could use either the Chrome web server, right? The one that we potentially installed. So if I go here to apps, I could go ahead and use this Chrome web server. What I'll likely be doing for this lab, though, is I'll actually use Node, and Node actually has a built-in module that's called HTTP-server that I can use to host a local server for testing as well. So I'll show you how I can actually launch a server using Node, and that'll be a primer for when we start building our web servers in the coming weeks moving forward. And again, this will just be a static server. So the only role it's going to play is to host the HTML pages and deliver that to the browser. So it's not going to be doing any kind of other backend requests except delivering web pages. So the motivation for our lab is we're going to learn the Fetch API and build a REST client and use JavaScript modules to better organize our app's code base. Our goal is to build a quiz game that requests trivia from a web server and maintains a shared leaderboard for all players. The learning objectives that we're going to cover, we're going to learn how to use the Fetch API and send requests to what are called REST endpoints. We're going to learn about REST client architecture for developing a distributed application. By distributed application, that means not all of the code base exists on the machine that we're running. Since we're making requests to some exterior service, suddenly our application has a dependency on another application that's running on a web server. And so now we're starting to talk about building distributed applications, where a part of our application is running inside the browser, and another part of the application is dependent on an external web server to provide data into our client. Eventually, we're going to learn how we can build both the REST APIs, custom REST APIs, and the front ends that will rely on that. And that's effectively what a full stack application will be. We'll make use of asynchronous JavaScript with the async await keywords, and we'll build async functions with that. We're going to use JavaScript modules with the import export statements for improved modularity of our code base. So really, we're going to compare how we build this game to the platform game. Recall the platform game, we had a ton of script imports we had to do, and we had to do them in a certain order. Modules is going to make building our code base much simpler, where we're not relying on the HTML to define all of our dependencies. And in fact, we won't even care what order we do our imports in. We'll make use of a classless CSS library in this lab. So this is an alternative to Bootstrap or building our own. There are other CSS libraries. This particular one will just provide a responsive style, and you don't have to produce any class names to the elements. It'll just kind of not naively produce a relatively attractive style. So we'll see this approach to building out a responsive web page. We'll look into scheduling and clearing timed events. And then we'll use the document object model to implement a single page application. So we've already been doing this where instead of having multiple HTML documents, we maintain the state of our document inside of our JavaScript environment. However, we're really going to take advantage of the fact that we now know how to use the DOM, and we're going to build an application that is going to be very React-like. In fact, this you could think of this lab as a primer to React. And effectively, it's my plan, my goal, that we will redo this lab using React, so you can see how similar it is to kind of create your own, to see what React is doing in the background. So we're going to kind of create a lightweight version of React. Our project architecture is we will have the quiz game, then we will have our HTML file right here, our index.html file, then we'll have subdirectories for styles, and then scripts. And our scripts directory, all of our source code is going to go. So we'll have like an app.js file, an HTTP JS file, and a view.js file. And we can think of these almost as modules where we can start dividing the responsibility of our code bases, and then all of our components, all of the HTML that we'll eventually want to write to the DOM, we're going to create JS files that are going to go in there that's going to represent those HTML elements that we're going to want to write or rewrite to our viewport. Okay, so let's start the way we always start. Let me go and grab okay, let's see here. Let me go to desktop. Let's just download it where it belongs. Let's go into, yeah, and let's go into labs. Let's save that, and there it is. Perfect. Okay, let me delete this zip. And let me rename this for the purposes of just quiz game. And what do I have here? So I have a README in here, quiz game. In this lab, you will build a quiz game with a leaderboard. See the lab document for further details. All starting files are contained within this repo. Scripts, components, a README. This is a directory that holds JavaScript functions that model an HTML component in the view. Organize all such components within their own directory to improve readability, browsability of the code base. So just some readmes in here. And then here's the minimal viable product.css file that will produce a responsive styling for us without us having to produce any class names. Now, the disadvantage of this is that we have less control, but the advantage is we don't have to care about doing any styling whatsoever. So we'll play around with that just to check it out. It's fun to play around with different things with each lab. Okay. So let me go back. Let me close this. So I have my starter files. So now let's go into the introduction on all the learning objectives in depth. So we talked about REST APIs, we talked about REST clients, and we talked about fetch. So a full stack app shares data between clients and servers via HTTP request responses. A browser is effectively a REST client when it depends on an HTTP request for data. So up till now, we were just building in-browser applications. The moment our in-browser application starts requesting external data, we can start thinking of what we're creating as a distributed application, and we can start thinking of our browser application as being a client to a REST API, or what I'll effectively call a REST client. So a REST API refers to the data that a server provides via an HTTP request. So an HTTP request, effectively browsers request data from a web server, and then the common methods that we can go ahead and request data is either to do a GET, which is effectively like a read, to do a put, which is effectively an update. You mutate something that already exists. You could do a post, which is to create a new thing that doesn't exist yet. And you can do a delete, which is to delete something. If you've taken databases, you would know these as CRUD operations, right? Create, read, update, and delete. Effectively, the same thing as what a CRUD operation is in a database is what you a request that you would make through HTTP to a web server. An endpoint. So a REST endpoint, well, we will have a crash course in databases again, but we won't use the Oracle database for this class. We're going to deviate out and use Mongo to give you something a little bit different than what you've already covered, just to expand your knowledge base. So if you don't recall that from database, it doesn't really matter. But if you do, then you can see kind of where there are shared similarities on how distributed applications kind of work in terms of data management and data persistence. In terms of the REST endpoint, the URLs on a server that listens to HTTP requests and returns back data. So effectively, the endpoints are just the addresses you go to for each in particular function you want to hit up. So some APIs are very simple. They might just have one or two different requests you can make. Some are very complex and you can make dozens or maybe even hundreds of different requests, and they're all on effectively their own URL, their own endpoint. And then fetch is a asynchronous JavaScript API that allows our browsers to send HTTP requests. Okay, so asynchronous JavaScript, what is that? Well, JavaScript provides non-blocking functions, which allows for other code to execute while our asynchronous function waits for the process to complete. So if this were a Java application, you would require that to be multi-threaded. You don't need threads in JavaScript. JavaScript uses the concept of essentially events. And so what will happen instead is when you have an asynchronous function, like a function that needs to wait on the server to provide data, it will go ahead and issue that and then wait for it to get back, but continue to execute the other instructions that it can execute until that response is delivered. So this is an important feature for any kind of network related task so that your code does not wait until the server responds before proceeding to the next task. So in terms of async await, any function may be declared as asynchronous with the async keyword. The statement whereby a IO, some kind of input output operation occurs, is declared with the await keyword. So the await is what we end up, that's what we're waiting for. But if you have at least one await invocation in your function, then the entire function has to be called async. And then what's happening? How does this work? How can we actually get asynchronous code working inside of our code base? Well, it's this concept of promise objects. An asynchronous function returns a promise object. This allows for the function to execute and then just to move on to the next task. The promise object is later resolved when the async function completes, thereby resolving the promise. What we do is we have callbacks that we trigger when the promise is resolved. Again, it's a form of an event. So when the promise resolves, it triggers an event, and then we bind a callback function that will do something in response to that event. And we kind of saw that again last lab with the contact form, but we're going to see it much more clearly in this lab. So let's talk about our JavaScript modules. So modules allow imports between JavaScript files without having to link the scripts in the HTML. So we can actually have JavaScript files talk directly to other JavaScript files. This provides for more readable, browsable, and scalable code. Modules require the HTML to be hosted by an HTTP server, though. So modules have their own scope that is not part of the global scope or function scope. So what we've learned up to this point is you can have variables or data scoped at the function level, and you can have it scoped at the global level. Now we're seeing that you can also have data scoped in the module level, and it only exists inside of that module. So if you needed to get data from one module to the next, you have to either import it or export it. So a module is an HTML document would link a script with the type of module. So we link them like we do normal scripts, but we have an additional keyword we have to apply. In terms of import, the import keyword allows a script to access functions or objects in its module scope. In terms of export, the export keyword provides an external access to functions and objects. These are returned as anonymous objects containing all the exported functions and objects. And then lastly, default, the default keyword exports a single function or object along with its name. Okay, so before we start this lab, we're going to do a mini crash course on JavaScript modules. Yes, the difference between .. and .. is critical. .. represents your path being relative to the parent directory, whereas .. represents your path being relative to your current directory. Okay. So before we move on, we're going to actually make sure we can do this. So let's create a, let's see here. Am I currently in LS? So I'm not in Quiz Game. So I'm going to create a new folder. Where did I create this folder? Oh, there we go. And I'm going to call it Module Tester. Okay. So LS in here. Okay. I'm going to go into Module Tester and let me get that bigger so it's easier. Okay, so now if I check, clear that. Okay, so there's nothing in Module Tester yet, but I am in Module Tester. So let me just create a bar.js. Let me create a foo.js. Oh. And let me create a index.html. Okay, so so first let's go ahead and declare a module in HTML and use, and I'll host this on HTML in just a moment, but let's actually get this in there. So let me go over here, Module Tester. Let's open these documents up. So I'll open this one, we'll open this one, and then we'll open this one. Okay, so I have bar, I have foo, and I have index.html. Inside my HTML, it's going to be super simple. It's just an HTML element that has a head element, and I'm going to import inside the head a script tag. Now notice the type that I'm declaring is a module. And then the source is going to be foo.js. And right now, for demo purposes, I'm just going to put them all in the same directory. Okay. So let me now host this on a server. So let me do clear. Let me do ls. Yep. Okay. So I'm in the directory of the index.html. So I'm going to use npm to execute a module that's built into Node that's called http-server. So now what I'm going to do is I just launched an HTTP server for my command line using Node. It's at local address at port 8080. So let me go here into and see if it brings me to an empty page, and it does. Excellent. And actually, if I go and inspect the elements, I could see, yep, there's my head, there's my body inside of the head. And there's my console. Okay, perfect. Now, the next thing I want to do is I want to go into bar and create an object or function and export it. So let's do that. So let's go into bar. And here, and just to test this out, actually, because I'll talk about what's going this, but since I have this, let me refresh my page really quick. Go here, do a refresh. Yeah, okay, see, I'm getting foo to print. So the reason why foo is printing is inside of foo.js, I have this console log. And so when I go and import this module, it's going to execute everything, right? That any instructions that are just on their own, just as it normally would when it first gets loaded into the runtime environment. Excellent. And that's because JavaScript supports a imperative paradigm in addition to a procedural and an object-oriented and a functional, which means I don't have to put my instructions in any kind of structure. I can just put them on their own and they will execute when they get loaded. Okay, so we know that this works. So the next thing I want to do is I'm going to create a named object that's just going to have some properties like it's going to have the name bar, type span, and age 0. But then I'm going to export. And since I'm using the default keyword, I get to name what the thing I'm exporting is. So I'm going to name it bar, which is the same name that I used here, but it doesn't have to be. It's going to export it with whatever name I put on this line. So here I'm going to export this object outside of this module. So now what I want to do is inside of my foo, I want to import the default exported function into foo.js. So let me do that. I'm going to replace this console log. And what I'm going to do is I'm going to import bar, the bar object that gets exported here. I'm going to import it here from, and then I give it whatever the file path is of the JavaScript module that I want to import. So since they're both inside the same directory, I'm going to use a relative path to the directory I'm currently in, and I'm going to import bar.js. And so that's going to now get saved into a bar variable inside of foo. So if I do console.log bar, I should be able to get the contents of the object that I defined in the other. So let's go ahead and go back here. Let's refresh. And there it is. So notice inside my console, I can see name bar, type spam, age 0. Now, one reason why this is so fantastic is look at my HTML. I was able to do that import without having to, I was able to get the data from bar without ever having to update the set of scripts inside of my index.html. So think about how cluttered and how difficult it became to manage our platformer game as we grew out the complexity. Using scripts to build out such an application became rather difficult. So we can rely on modules to give us that same kind of script to script behavior that we expect from a language like Java or a language like C++ or a language like C#. So it gives us that an ability to create larger scale applications very flexibly without the overhead that we had in Lab 4 on the platformer game. Excellent. So this is now working. So I'm happy with these results. So now I can go here. Let's see here. I can let's kill my server. And actually now if I refresh it, you'll see I now can't reach that page. And let's go ahead and clear. Okay. That terminal. Excellent. So now we're ready to move on to our lab because we know that we can actually get our modules to work with the approach that we just did. So now let me go to ls. I'm currently still in there. So I'm going to change it to the parent directory, but then go into quiz game. So now there's nothing, there's README, scripts, and styles. Perfect. So let me clear that. Okay, so let's move to part 1, where we're actually going to build out our quiz game. And so in this instance, this is a small sample of what we're looking to kind of build out. Quiz game, we'll have a time, we'll have a score, they'll have a category and a difficulty and a question. And based off the question, we'll have a selection of possible answers. So it's multiple choice, and we'll have the ability to skip. So this is what we want to have done by the time we're complete part 1. So the way that we're going to do this, though, is we're not going to write all these quiz questions ourselves. We're going to rely on this service called Open Trivia Database. It's free to use. It's user-contributed trivia question database. So this is an open trivia database that provides a completely free JSON API for use in programming projects. Use of this API does not require an API key. Many of them do. So when you go to build your own REST client, you might have to find a service that relies on API keys, but this one doesn't. You just use a URL with the search params, and it will go ahead and return to you a JSON with the data that you need. So let's actually take a look at this. I'm going to, when we go there, effectively our API helper, our API overview is going to be, we have 5 different parameters. The first is the number of questions you want delivered. The second is the category for the question. The third is the difficulty of the question. The fourth is the type of question, whether you want true or false, or you want multiple choice. And the last is going to be your data encoding for sending into the browser. So their website allows an easy URL generator such that you select the parameters you want and it generates the REST endpoint for you. And since the entire REST API uses GET requests, you can use the API in the browser just to test it out. And so I give you an example here that we could test out, or we'll just create. So let's say we want one question. Let's say that we wanted to create a computer science question. Let's say it could be any difficulty. Let's say that it always has to be multiple choice. And let's say that we'll use just the default encoding. So we're going to generate that API. And then what I should have when it does that, there we go. And then it's going to generate an API and then publish it right up here. Although I think I refreshed. Let me get at least one. Let's do this again. Computer science, any multiple choice, generate API. Okay, perfect. So now you'll say you have this URL to effectively this PHP application, and then you have the search parameter that's a key value pair that if I send that request there, it's going to send back a JSON into our browser. Let's test that. And yep, there it is. I can see response code 0, result, category, computer science, type, multiple choice, difficulty, medium. The question is, what 5-letter word is the motto of the IBM Computer Company? The correct answer is think. The incorrect answers is click, logic, and pixel. So we're going to have to know how to parse this in order to build our questions, but we can see every time we send this request, it's going to send us back this JSON object, right? And it's going to be a different question each time. And then if I change this parameter for amount, let's say I do it to 10 and then refresh, 10 and then hit enter, it's going to give me that many questions. Excellent. So we can see how requests can be made to a backend web server. Okay, excellent. So that's our first part, learning how to use the API. And so now I think we've done that. So the next part we want to do is, well, can we use a GET request to the REST API to go ahead and get some trivia data into our JavaScript runtime environment? So just like all of our other labs, we're going to break this into an approach, apply, and an assess. So our approach will be use HTTP GET requests using fetch to go ahead and request from the web server's REST endpoint to get trivia data into our browser. So to do this, our first step is going to be to create an HTML file that links the CSS and JS files, and that has an element for view that we will use the DOM to access and then write into. Because remember, this is going to be a single page application. So this will pretty much be just our HTML. We won't mutate the HTML after this. Everything else will happen in JavaScript using the document object. Okay, so let me go here. So, okay, so the first thing I need to create an index.html. It doesn't already exist, right? ls, nope. So let's create, no. That Okay, so now I have an index.html. Let's actually put some contents in there. So let me go to my quiz game, into index.html. I'm going to drag it into here. And so we're going to put the following HTML in there. So I'm going to create an HTML element. Inside my HTML element is going to be a head element and a body element. Inside the head element, I'm going to link the style sheet, which comes with the lab. It's that MVP that will provide attractive, responsive styling without us having to apply any class names. And then I'm going to go ahead and use this script keyword, and I'm going to import this as a module. And the module I'm going to import is the app module. And so since I'm importing the app module, I won't have to do any other imports from the HTML side of things. I'll be able to do it directly between JavaScript files. And then I'm only going to have one element in my body. I'm going to use semantic HTML to create a header element. I'm going to give it the ID of view so that I can access it from my JavaScript runtime environment. And then any kind of update to my viewport will happen from the JavaScript. And I'll use the view ID to do that. So now I'm done with my index.html page. So the next step I want to do is I want to create a http.js file, which will be responsible for sending my HTTP request to the web servers. So I will define an exported function that sends an HTTP request, GET request to a REST endpoint. So let me grab this and then we'll see what, well, let me first make, so let me do this, ls, let me go into scripts. Clear that, do ls. Okay, so all I have is components. So let me go and create something called http.js. Excellent. So now that should be in my scripts directory. So let's go over here into the scripts directory. There it is. And let's just drag that into my IDE. And let's, oh, no, don't want HTML. Let's grab the contents of this and then we'll step through and actually see what's happening here. So I'm going to create a function, assignment, a function assignment. So notice I'm using the keyword export when I define this function. That means that this function will be available outside this module if other modules, if other scripts import it. So in addition to that, it's constant. So I can't change the implementation of this function. Function name will be called send get request. And then I'm going to assign, this is a function assignment. This is going to be an asynchronous function. And it makes sense it's going to be an asynchronous function because we're going to have to fetch data from some backend server. That's what a send get request is going to do. We're going to pass it a URL, and effectively we're going to define our function as a fat arrow function. So we're going to pass in a URL, and then we're going to give it an implementation. Inside the implementation, we're going to create an empty object that we're going to call options. And again, we're always going to prioritize using as little privilege as possible. So if we can label things as constant, we will. And since we're only going to mutate the state of options, but never actually change the reference of it, it can be constant. And then inside of options, we're going to give it a method, which is going to be the HTTP verb that we want to send as a part of our request. And we're going to send a GET request because this is a send GET request method. Then we're also going to go ahead and make a call. We're going to make a fetch call. So fetch is asynchronous. We have to go ahead and invoke it alongside await, which is why this method is async. We're going to use the URL as our endpoint and then the option with the method get, so we know which verb we're trying to utilize. And so this will resolve a promise object that will eventually become our response. We're going to await for that response to resolve. So we can do an await on something and it'll trigger when it resolves, and we're going to request the JSON from that. So the response object will contain a JSON data, and we can extract that JSON data as an actual JavaScript object using this method call, and then we will store that in data, and then we will return that data from this function. Excellent. And again, all of these comments are right here. So now that we've defined that that function that can send an HTTP GET request to an endpoint, the next thing we want to do is create an app.js file. And we're going to want to import all of the exports from our http.js as HTTP and initialize a trivia GET endpoint and the game state. Okay, so let's start by creating that core app.js. Perfect. So now let me go here. I have my app.js. Let's get that in there. And here. So what I'm going to do here is I'm going to import everything. Star allows me to import everything. And I can give it a label as HTTP. So it'll go ahead and put everything into HTTP. Essentially like an object HTTP. And I will go ahead and do that import from the starting at the current directory / the http.js script. And then inside my app, I'm going to define my get trivia endpoint as HTTPS, whatever the generator gave to me here. So I can look at it. This part is the URL. And then this is the search parameter term, the question mark, amount equals 1. So 1 question, and difficulty equals easy. So always easy questions, but it can be of any type. And then I'm going to maintain the state of my application inside of an object, an empty object that we will call state. Excellent. Okay, next thing I want to do is inside of app.js, I want to define a play function to play the quiz. For now, we're just playing will just be to print the result of our GET request. So let's go into our app and let's actually do a function. So again, we're going to use function assignments. So play game will also be an asynchronous function. It's going to be asynchronous because we're going to rely on send get request, which itself is asynchronous. So notice how this can start chaining. So we're going to wait for send get request to return back a response object. Well, actually data, right? Because if you remember, if we look in here, it gets the response, but then from the response, it gets the JSON, which will be a JavaScript object, and it's going to return the JavaScript object. So we're going to wait for it to return our JavaScript object, and we're just going to log that in to console.log. Now notice, since I imported everything as this label, I'm going to get that function available to me inside this HTTP object. Okay. And so the next thing I need to do is we need to go into our app script, and on Windows startup, we are going to define a global start function to launch the app and have it execute when our initial window loads. So let's go here. There we go. So on window.start, so when the window initially loads into the browser, this asynchronous function is going to get called. The reason why this is an asynchronous function is because, well, play game is an asynchronous function, and play game is an asynchronous function because it needs to wait for a response from the send get request method inside of HTTP. And then we will go ahead and invoke that. What that should do is send a request to get back some data, and we'll just log that out. And so we're going to add in the window an event listener such that when the browser loads, we will invoke this start method. And the start method is inside the global scope of our browser. Remember, the window object is the global object. So we're going to find a start method that allows us to start our game, and then the rest of our game will be defined inside of our module scope. But since we're in module scope, the reason why we have to produce something in global scope is so that we can have a launch point for our application. Because right now, none of what we're writing is available inside of the window object. So we need a starting location, like a main method of sorts, to launch our application. Okay, perfect. So let's see what we do next. We now can go ahead and test our other application. So we're going to use an HTTP server. So again, in order to do this, I need to host. Let's just do npx. Oh, npx will allow me to use the Node Package Manager to launch an application directly from the terminal. And then HTTP server is a built-in core module that's part of Node. And when I launch that, I'll listen on local host at port 8080, which I already have open here. So let me refresh. And actually, that's not going to work well if I'm not in the right directory. Let me get into the right directory. Clear. Where am I? I am inside of scripts. I need to be inside of the directory that has index.html. I am now. So I'm inside quiz game. So now let me relaunch my server and let me try to go ahead and refresh this page. And yeah, there it is. And look at what I get inside of my viewport here. I got a response. And inside of my response is I got a response code here. This is a JSON. I have a results array. Inside of my results array at index 0, I have category, entertainment film, correct answers, RoboCop, difficulty is easy, incorrect answers is Blade Runner, Terminator, and Predator 2. And the question is, which of these films is not set in... I can't quite read the rest of that, but you get the idea. Is it in the future? I don't know. Set in, it doesn't matter. You can see we got the question. So we can move on to our next step. Our next step is, well, we want to display that trivia question to our DOM. So the approach that will orients to the viewport. So our approach is, well, use the document object model API to access the HTML element that has the view ID, or the ID view, and set its inner HTML with the question text. So now what I'm going to do is, since I want to manage all the authoring of my HTML elements from JavaScript, I'm going to start creating JavaScript scripts that represent each HTML element that I might want to render into the viewport. So I'm going to create inside that component subdirectory a new script that's going to be called question.js. So let me go into here. Let's kill the server. Okay, let's clear out all this. So right now I'm still in quiz game. So let's go into scripts, and actually let's go into components. Let's see. Yeah, let's go into components, and let's actually create what's going to be called a question.js. And let us go here, scripts components, question.js, perfect. And here, I'm going to define a function, question. I'm going to define it with an uppercase letter because it's effectively the functional equivalent of what a class constructor is. So I could have implemented this in one of two ways. I could have used the class keyword, but in this application, I want to familiarize you with a functional programming paradigm instead. So we're going to build this application using a functional approach. We're going to do that because React uses a functional approach. It does give the option for a class-based approach, inheritance class-based approach, but it's more common to use functional approaches when using GUI frameworks, front-end frameworks. So effectively, we can think of this as almost like a constructor that creates a HTML element. It will take in a trivia object, and then I'm going to go ahead and use the string template that's going to create a heading element that's going to have a div, and then I'm going to dereference from the trivia object the category. I'm going to dereference for difficulty the trivia, the difficulty. So again, this is from the data that we'll be getting from the object we got back from the trivia API. And then we'll go ahead and then create a heading for element. And in a paragraph tag, we'll go ahead and dereference inside that trivia object that gets passed in the question. And so that this could actually get used, we will then export. And by using the default keyword, it will be labeled as question. So we'll be able to export this question function so that we can use it elsewhere in our app. Okay, so now that I have something that can author HTML that represents a question, let's go ahead into our view. And we don't have a view yet, so let's make a view. So let me get into just the scripts directory. So let me make sure, let me clear here. Oops. What's going on? Okay, perfect. So here I'm in the scripts directory. I'm going to do ls right now, app.js, HTTP.js components. So now what I want to do is I want to create a view.js, does not exist yet. Let's get that into our IDE. And inside of our IDE here, we will import question from components. So again, this will be from the current pathway that we're in. There is a component subdirectory, right? This component subdirectory. Inside that component subdirectory is that question.js file. So for our view, we're going to import that question function that allows us to author a question in HTML. And the next thing I want to do is I want to go ahead and create a function inside of my view that I'm going to call render DOM. So let's take a look at this. So here I'm going to create a function render DOM. It will take in an HTML element, some kind of HTML, and it will call document.getElement by ID, and it will grab the view, the element that has the view ID, and it will set the inner HTML of this, right, of our header with whatever this HTML is. So we're going to be, so if we build our HTML tree and pass it into render DOM, we'll be able to render all of our HTML in one go with this function. So this is what we'll rely on to be able to display HTML into our viewport now using JavaScript. So then the next thing I want to do is I want to define an exported function that renders the play scene. So this is also going to be done in Vue. So let's go here. So here I'm going to create a exported function. So that means that this can get imported by some other module. It will be called play scene. So notice I'm using like uppercase letter. I'm representing that I'm creating some kind of action, but it's a function, right? So it's going to take in a collection of properties. So it's going to be an object. And so the implementation is I will destructure from the properties object trivia data, the trivia data. And then I'm going to invoke the render DOM function that I had just authored with the contents of me to effectively invoking this question, the question function with the trivia data. Now, remember, when I invoke this question function, it's returning back to me HTML, right? So this is going to return back to me a string that is HTML, and I'll just take that string and I'll label it inside of this string template. And so then that will then get added to the view element's inner HTML here, since it's doing that invocation there. Excellent. So now what we want to do is we want to go into our app and import our Vue.js so that we can control drawing to our viewport all the view functions from our app. So here from the very top, I'll keep my imports together. I will then import Vue.js. And so now, instead of that console log, I'm going to go into my play game and I'm going to update that. So inside of here, instead of just printing that inside of play game, what I'm going to do is I'm going to get the JSON results. So remember, there was that results array. I'm going to destructure that. So I just get the trivia data because we're only ever asking for one question, right? Right here, the amount is 1. So we're only ever getting one question. So I'm going to dereference that from the state, the trivia. And then I'm going to send that into the play scene. And so remember what play scene does is that's inside of Vue, right? Because we imported all the functions inside of Vue as Vue. So from Vue, we will invoke play scene, which will pass in these properties, which will destructure the trivia object and send the trivia object to the question. And then that's going to invoke the question with the trivia data that then is going to return back this string that is HTML values back to Vue, which will then tell that to render to the DOM. And so now if I go and launch, so let me get back to make sure that I'm at the index HTML. And let's launch our server. Okay, so now that I have my server launched, let's go ahead and refresh. And look at that. Instead, now I'm actually rendering category entertainment television, difficulty easy, and a question. In which state of America was the Fresh Prince of Bel-Air born and raised in? And if I refresh the page, it'll make a new request and give me a new question. Excellent. Okay, let me kill the server for now. And let's also clear it. Okay, perfect. So now let's move on to 3. In 3, we can now get the questions to display, but let's consider, well, let's also provide the ability to show the possible answers. So our approach here is we will define an options component for our HTML of a trivia options and use it for the questions component. So let's go here. So right now I'm inside of quiz game. Let's go into scripts. And inside of scripts is components. We want to build a new components, which is an option for the player to select. So let me create that. And so I'm going to call that with an uppercase options.js. And again, I'm using the same conventions that would typically be used inside of React. This is a good primer for React. Okay. So now that I have options, let's go ahead and define a function that's going to return the HTML for a trivia's Boolean options. Remember, there's one of 2 options we could potentially have. So let's go over here. We have options. Let's open that here. So we could either have a true false question or we could have a multiple choice. Oh, no, not. Okay. So let's go and get our implementation here. Okay, so on the instance of a Boolean option, we're just going to create a function that returns back a div that has 2 buttons, true and false, and both of them will have this on click where it's going to go ahead and evaluate a check answer and pass the message true, and on click check answer false. So you can see we're already handling something, or we intend to handle a user event when they click on one of these buttons with message passing to the same button, check answer. Okay. So the next thing I want to do is I want to define another function inside of my options.js that will return the HTML for trivia's multiple choice options. Now notice I'm not exporting these. These will be the decision of which ones I'll utilize will be made inside of this script in this module itself. So here I'll create a multiple options function that, given some trivia data, I will go ahead and I will use the spread array to break the incorrect answers into a collection of strings themselves, and then I'll encapsulate that to build a new collection that is the correct answer along with the 3 incorrect answers. So this will be a list with all the answers, and I will call this options. And then I will just tell the options to sort so that they're always in alphabetical order. And this way, the answer and the incorrect answer are all mixed up. We don't know which is which. And then I will store those into A, B, C, and D. This will return back an array. So I can destructure the array and bind them to variable names using a destructuring call so that I get the first element in variable A, the second element in variable B, the third element in variable C, and the fourth element in variable D. And then what I return back is always going to be some HTML. So in this instance, it's going to be a div tag. So notice we always want to contain our element. So if there's more than one element that we want to go ahead and provide back, we wrap it in a div tag. So here we wanted 2 buttons, but we didn't just return buttons. We took the 2 buttons and we wrapped in a div tag. So we were returning 1 element. So the idea is that we're only ever returning 1 element, even if that 1 element contains a collection of other elements that you really want. So here for multiple options, we want to have 4 buttons, but those 4 buttons will be nested inside of a div tag. And they all have an on-click event where it will check answer. We'll call this helper method called check answer. But here we're going to pass in whatever the value of A is, or B, or C, or D into check answer. And then we're also going to add that as text in between the elements, the HTML elements. Excellent. So now the third thing I want to do is I actually want to define a function called options that will decide which of those 2 things to do. So let's go. So we have a Boolean options. We have a multiple options. So my options will take in some trivia data, and it's going to use a switch statement based off of the type. So if the type case is Boolean, then I'm going to return back a Boolean option passing in that trivia data. And if the case is it's a multiple, then I'm going to return a multiple options. So this just makes the decision on whether I should give a set of true false buttons, or whether I should give a set of buttons that has a collection of 4 different answers. And then the only one I'm going to export is going to be the options, because the logic of which one it actually gets is done internally inside this module. So I'm going to export by default using the term options, and options will be this thing. So this is the one thing that gets exported out when I import this module. So now that I have that, let's go into our questions JS file and actually import this options. So let me go to my questions at the top, and let's actually go ahead and import options. And so now that I have options, when I go and have my function that produces the HTML with the question, I can add to it after the question. I can make an invocation to options and pass the trivia that got passed into question to options to get the necessary options. And you could say, I'm not going to have to mutate app or view or anything else. By doing this, I should get my answers alongside my question. So in order to test this, I should be able to just run my app. So again, I'm inside of components. So let me go back to scripts, back to the root directory of my project into quiz game. Let me launch my app. So npx http-server, I'll use Node to do that. And then let me go into here and hit, and there it is. Now the buttons don't do anything yet, but now you can see I have true or false. If I hit refresh, and you can see that responsive design from that CSS that we're using. And then we have multiple choice. And then with each request I do, we could say, yeah, awesome. This is very cool. I get all of my possible, and since it's in multiple, since it's been sorted in alphanumerical order, I don't know which one is the right one or wrong one based off of the ordering that I'm rendering it in. Okay, perfect. Let me go ahead and kill my server and clear. Excellent. So now that I can render questions with answers, oh, I guess I want to come over here. The next thing I want to do is I want to define a timer event and actually display that into my HUD. So I'm going to refactor my game state with initial properties. Right now, it's in an empty state. So I want to give the properties of a score. So my score is going to start at 0. I'm going to have a timer. My timer is going to start at 20. A interval that I will set to null, and then a trivia question object that I will set to null. So these are just things that I'll manage over the course of my application that I'll be able to maintain. So here, let's go ahead and set that. So a score, a timer, my interval ID, so that which will be the timer event. So this allows me to clear the timer event when I don't need it any longer. That's what the purpose of that will be. And the trivia is the current trivia object that I'm using. Okay, so now that we have a ability to manage the state in our game, the next thing we're going to do is we're going to define a new function that checks if the timer is non-zero and then decrements it and renders our play scene. So let's check that. So let's go into our app.js and create this function. So we're in app.js. I'm going to do it above the window.start. So I'm going to keep all the module implementation together. And so here, countdown is going to be a function. And so if inside of my state, so I have a state object, if inside a state I have a timer, if the timer is non-zero, so 0 resolves to false, a non-zero value resolves to true. So if that's a non-zero value, I will decrement timer, and then I will tell the view to go ahead and play the scene with whatever the current state is. So I'm going to pass play scene with this data here. So we can start using that. So the view can start rendering a HUD. So now what I need to do is inside of my app.js, I need to find another function to set the timer and schedule a countdown interval and call the play function. So let's do that. Let's create a function that will create a game for us. So here's a function that will create a game. What it will do is it will set timer to 0. So it will mutate whatever the state of it is here. And then I'm going to set interval, right? I'm going to register. I'm going to schedule a timed event. The callback function will be countdown, and it will trigger that every 1,000 milliseconds or 1 second. And I'm going to register this timed event as my interval ID. So this returns back an ID, and I can use that to clear this from the scheduler. And then after I do that, I'm going to go ahead and invoke the method play game. So then what I need to do is inside of my start, instead of telling it to play game, I'm going to tell it to create game instead. So here, I'm going to update this inside of my Windows start to be create game. And then what I'm going to do is I'm going to define a function inside of my HUD. So I haven't created this yet, so I'm going to have to create a HUD. And I'm going to, since the HUD will be represented as a set of HTML elements, I'm going to put that inside of my components folder. So let me go into my scripts and let me go into my components. And now that I'm in there, I'm going to create a new HUD.js file. And so the responsibility of this is just to render the HTML contents that will make up my HUD. So let's go here and here. Perfect. And so this is just a function that, given a value for timer and score, is going to create a set of HTML elements that actually, this should actually be inside a div itself. It should abide by the rules that I stated. That we should strive to just return back one HTML element. And if it requires multiple things, nested so that it's an individual HTML component we're returning back that then has children elements. Okay, perfect. And then I'm going to export the HUD. So the HUD is just going to say quiz game, and then it's going to have time, and then whatever the timer value is, score, whatever the score value is, and then it'll give a horizontal rule. So then what I need to do is, inside of my view, is in addition to importing a question, I also want to import my HUD. So let's go to view. And right now I'm just importing the question. So let's also import the HUD. And so now that I've imported it, I can update my placing. So I'll just grab the updated placing and we'll take a look at what is happening with it. So so right here, giving a collection of properties, I'm going to destructure the properties as a timer, a score, and the trivia question. So remember, what's getting passed from the app is the state object, which has all these attributes. And so now, since I've destructured these, I have them in individual variables. So to the HUD, I will send the timer and score, and that's going to render the HTML that I need. And then to the question, I'll send the trivia, which will go ahead and render the question along with the answers. And I see right now, just for those of you who are on the hour and 15 limit, we've hit that, but I'm going to just continue for this first part to be where I want it to be inside the video. So I will post the video and you'll have access to it. Okay, so now my render DOM, every time it's called, or whenever placing gets called, it will tell the render DOM method to include the calls of these two invocations. So it'll get the HTML from the HUD and then the HTML from the question. So let me save that. And that's it. I should be able to go ahead and test this out. So again, we have to use the HTTP server. So let me go back to where the index.html is. So right now I'm currently in components because I made the HUD last time I was at the terminal. So now I'm inside of quiz game. So let me use npx to do http-server. Okay, so now I've launched this. So let me go over here and let's see what happens here. Ah, beautiful. So I have game quiz and I have a timer, and notice my timer is counting down, and I have a score at 0, and I have a question, and I have a collection of answers. We're getting something that's looking much more like a game. Now, we're not handling everything we need because, well, look at this. Our timer got to 0 and then it stopped. Excellent. And the reason why I did was because of the countdown here, right? Because the moment it becomes 0, we stop invoking countdown, right? Okay, let me go and kill the server. I'm gonna Control-C that. Okay, and let's clear that. Perfect. So the next thing I want to do is I want to display a game over screen into my viewport, into the DOM, if the timer runs out. So if the timer ever gets to 0, I want a game over scene that has a button to start a new game. And so in order to do this, I'm going to go into my app.js and refactor my countdown to clear the timed interval and show a game over scene. So here inside of our app, we have countdown. Right now, it checks to see if it is not 0, but if it is 0, then what we want to do is clear interval with the scheduler, that timed event that is our interval ID. And then I want to make an invocation to our view object to invoke the game over scene and pass it the state of our game. So we need to define a game over scene. So let's go into view. Let's go into our Vue.js here. And we're going to create an exported function. Of course, there's got to be an exported function because we're invoking it. It gets invoked from our app module. So we need to export it from our Vue module so our app module has access to it. It will take in properties. The properties, as you might recall, is the state. We're passing the state. So I'm going to destructure the state as the timer, the score, and the trivia. And then I'm going to tell this render DOM function to go ahead and invoke HUD with the timer and score. And also to go ahead and produce a heading 1 element that's game over, and to create a button that has a on-click event that can go ahead and invoke a start method. And this will say start menu. And so once I do this, I should be able to test this out, right? And see if I don't get a game over with the start menu. So let's test this out. I haven't changed directory, so I'm still inside my quiz game. So I'm going to go ahead and use npx to launch a web server, and then I will refresh my page here. It should start a new game, and I will wait for 20 seconds to pass and see if my viewport doesn't update with a game over screen. And beautiful. Game over, start menu. Now, again, it doesn't do anything yet. Let's go ahead and kill this server. And we will clear all that mess out of it. And the next thing I want to do is I want to display the next trivia to the DOM. So when I want to offer the player an option to skip a question and request a new one before the time expires. So to do this, I'm going to create a new component that will be called the skip component. So let's change into my scripts directory. Inside my script directory is components, and I'm going to create a skip.js file. Perfect. And actually, let me grab the code, and then we'll take a look at what this component's going to do. Okay, let me go in here. Inside of components, we have skip. Let's get that into the IDE. And so it's going to be a function that just returns a div. Inside the div is a button that has an on click that will invoke play game. And it will be called skip. And then I will export and default call it skip, so that when I import, I can just import a skip. Excellent. So now what I'm going to do is inside of my view, I'm going to import the skip. So I can append that. There we go. So we're going to import the skip component. And then what I want to do is every time I go to render the play scene, I want to render the HUD with the timer and the score. I want to render the question with whatever the trivia data is, and then I want to render a skip button. So let's go into my play scene. Okay, and so after the question, I want to invoke the skip button and make this part of the string that we're passing to our render DOM function. Excellent. So now I want to refactor my play game to be a global scope so that the event dispatcher also has access to it. Because remember, so long as it's in module scope, we can't necessarily access it. And so now we need to update this so that we can also give access to it to the global scope so that our event dispatcher can handle that. So let's go to app and app.js. Let's go to app.js and play game. So right now, this was its own thing, but we're going to change this so that the play game now can be triggered by events, or it can be a callback function if necessary. Excellent. So now what we can do is let's actually test that out. So let me go back to my root directory that has inside a quiz game, and let's launch the server. Oh, whoops, not npm. It's got to be npx. Okay. And here we go. Let's refresh. And so now I have a skip button. And when I skip, it gives me a different question. So effectively what it's doing is it's just invoking play game again, but it's maintaining the state of my timer, right? So I'm not restarting. I'm just able to get another question before my timer runs out. Excellent. So I have one last thing that I need to do for this part of the game before it's complete. I need to be able to handle being able to submit an answer and then handle the result. So what we need to do for that to work is recall that previously on side of our options, there was that check answer function that we were invoking, but we haven't done anything with that yet. So now let's define that check answer function to determine if the player is correct or not. So we're going to do that inside of our app. And so to ensure that our buttons have access to it, now remember, our buttons are calling functions inside of our global scope. Every time we're doing an on-click function call from there, it's going to look at the window object for these. So we're going to register the check answer function to be part of the global scope where the buttons are also located at effectively, or where the buttons are going to try to invoke functions from because they don't have direct access to the modules. The modules are on their own scope. So let's go into our app.js file. And inside of our app.js, we're going to create this check answer function that's going to register this function as part of the global object. And given an attempt, so this attempt, remember, comes from, let's go to options. Remember, we have these on clicks that are passing in strings, either true or false, or whatever the actual value of the answer is. So what's going to happen here is it's going to be when the check answer button is clicked, it's going to be passed in a string value. So what we're going to do is we're going to, from our state, get from the trivia data the correct answer, because remember, that was one of the values that we have direct access to, and we're going to save that as the answer. And then we're going to check to see if the attempt is equal to the answer. And if it is, we'll increment the score with whatever the value of the timer is. So you get a higher score based off of the time. And then we'll actually add more time on the timer, which means that you can keep building a higher score. So we'll add to both the score and the timer. The quicker you can answer it, or the more timer you have, the higher the points are. And then we'll invoke play game, which means that you'll get another question to answer. Now, if you get it wrong, we will clear the interval and we'll invoke the game over scene. So this is going to be a very ruthless game. Instead of decrementing points if you get it wrong, the first question you get wrong, you just lose. That's how we're going to handle that, just to make it easy. And then once we do that, that's it. We should be able to use the HTTP server and open our index HTML and see if we can play the game and get the correct answer. Hopefully we can get the answer. I think I even have my server still running. So let's see if I can just refresh with those changes. Okay, what's the answer? What's the name of a singer Frank Ocean's second studio album, which was released in, I don't know. Does anyone know the answer to this? Oh, I got it right. Look, score 8, and I got more time. Okay, and let's just do that. Okay. Nope, I got a game over that time. Wow, I was incredibly lucky. I got 34 points just randomly clicking on questions. But look, I was also able to go ahead and get a game over. It tells me the time I had when I got the game over and the score that I had. So I have what feels like a full and complete quiz game that I've built. And I was able to build a REST client inside my browser. I depend on this open trivia API to go ahead and import these questions. And then I've used both modules and the DOM effectively to build out a scalable application that looks nice and clean. Like if I look at the quiz game here, remember what my index.html looks like. It's just this. Super. I never had to update it throughout the course of building out my application. And all my components, as I needed each new component to render, I could define it on its own and programmatically go ahead and insert that into my DOM tree. And then just keep those all archived by themselves. So all of the core logic exists in app, HTTP requests exists in this module, and all my viewing, all the thing that gets rendered into my DOM goes here. And then all the individual components that the view relies on will go in here. Very clean looking architecture. So that's going to be it for part 1. Thank you for sticking around if you had to, I guess, for a little bit longer than we had. And then on Thursday, we're going to finish this lab out and do part 2, where we actually add a leaderboard, a global leaderboard, a public leaderboard, where everyone who plays the game will share between the top scores. And we'll look at using a different API, use 2 different APIs in our game, one for the trivia questions and then the other to be able to go ahead and store the data for our leaderboard. So before I end today, let me just ask, does anyone have any questions about what we did? And if not, then I will go ahead and, okay, great. Well, then I will go ahead and end today's lab video. Thanks everyone for being part of it. So.